Hi, this is Stephen Ryer from Wright Raleigh Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And this is an addendum to Irvine Chapter 12. After I created a lab for Irvine Chapter 12, I realized that the videos that I created for Irvine Chapter 12 were missing one little piece that I wanted to go over. And what I want to do is, before going into it, I want to then show how something would be done first in integers, show a limitation that the integers have, and then go into the floating point. So, which means we're about to see this thing is not going to compile, but I'll go and I'll fix it. So suppose we have the symbol here, price apple is 2, and suppose we have a variable that has the num apples sold is 7. And then here we have the apple sales as being a D word. So this is all dealing with integers. And so the net effect of what I want is I want to multiply 2 times 7 to come up with 14 and stick 14 into this variable in memory. What I might think I could do is if I load EAX with the number of apples sold, then I can multiply by the price apple, which is the 2, and then EAX would have the result, store that into memory, and then just display that value on the screen. But what happens is when I try to compile this, I get an immediate operand not allowed. The reason why I'm pointing this out with the integers now is because we're going to have a similar thing with immediates not allowed when we're dealing with the floating point stack. So I just want to point out that here we weren't allowed an immediate as an operand of mul when dealing with integers. So a way around it is if I load the price apple, which is still here up this constant, and I load that into EBX and then do a mul EBX, then EAX is going to have the net effect of the number of apples sold times the price, and then I can move that into sales. And so if I run this, we should get our apple sales as being 14. Okay, fine. But this is floating point, the chapter that we're in. Yes, so imagine if, and let's just come back up here, I want the apple sales to be real 8. And suppose I'm thinking, and I'm going to, this is an issue, we'll come back and finish, that I want the price of an apple to be $1.75. That's one hell of an expensive apple. It's got to be one really good apple. Okay, so I'm thinking, but I still want the number of apples sold as an integer, a whole number, thinking I can't sell half an apple. And in terms of what changes we would have to make, well, we're not dealing with EAX, and so if we're dealing with the floating point stack, then what I would need to do is take this integer, FILD, the number of apples sold, and so I need to load the number of apples sold onto the stack, the FPU stack, and so then what you might be thinking is, well, let's go and load this price apple onto the stack. So you might be thinking, okay, let's do an FLD, the price apple. Oop. Happen to have a copy of it here. Load this onto the stack. I'm making a mistake, but I'm illustrating a point eventually onto the FPU stack. We'll fix it in a little bit. And then for the multiplication, fmul without any operands, I'm thinking this will take, so the top of the stack should have the value for the number of apples sold times the price apple. Now we're going to come into another issue here for a second, but if I want to store what's on top of the stack in the memory, that's going to be, if I do an FST into apple sales, that will store value on FPU stack to memory. And then a change I would do here is I would do the right float. And let's just add a and at the end. So the thought process is load the integer onto the stack, load the price apple, the constant that I have here, onto the stack, and then do an fmul. And I said earlier we're going to have an issue. The issue we're going to have is going to be here. So if I try to compile, syntax error. And so you might be thinking, oh, yeah, the problem is I forgot the radix. Yeah, I should put the radix as VR. No, still doesn't like it. The symbol definitions don't work with the reals. It's like, what do we do? We'll have to have a variable. So I'm going to actually have to have a price apple as a real 8. And by the way, I'm using real 8 for everything. I could use a real 4, but humor me. I'm just putting a real 8. We have a lot of apples we're going to sell, and a great deal amount of precision. And I want this to be 1.75. So this is going to be the price of the apple, which this is a variable as opposed to a constant. And so this is taking up memory. So the price of an apple. And so then the difference here would be we load, price apple onto the stack. So the price apple is loaded onto the stack. And then the product, we would have the number of apples sold times price apple. Okay, so 1.225 times 10 to the 1, so that's 1225. So the 7 times the 1.75 is our 1225. So for loading onto the FPU stack, we use FILD for loading the integer, because we still want a whole number for the number of apples. FLD, now in this case here, we do have to create a real variable for the price apple in order to use it. And by the way, if you remember, an FSTP would remove what's on the stack. So this leaves the value. So why don't we say copy value on CPU stack to memory. And the reason why I say that is if I were to add out of giggles and grins here, so let's display the FPU stack. And we'll see that when we're done, we still leave this value on the stack. Now, part of it, you might say, well, it doesn't really matter. This program is done. And if we only had one program, we might not care about it. But suppose this chunk of code is in the middle of a larger program. And what we really kind of wanted to do is the entire chunk of code, there should be a net effect done, meaning if there was stuff previously on the stack before this was called, we want to make sure that we leave it that that stuff was previously there. Kind of like doing the cleanup. But we left this here on the stack. So one of the things you might notice, like if you do a Google, one of the things you might see as a suggestion is you create a dummy variable, call it dummy, as a real 8, and then do an FSTP dummy, which will take the value off the stack, and then put it into the variable which we don't care about. Another thing that can be done, if I do an FSTP, ST 0, then this will remove the item on top of the stack. Okay, and so now by doing that, by doing this FSTP ST0, and boy, you might be saying to yourself, wasn't ST0 what's on top of the stack? Yes. So in a sense, we're kind of popping it onto itself, but it just removes it from the stack. And it is a way to get a value off of the stack. Okay. The one little thing that is not part of this demo, and I'm just going to do, since I'm going to be loading this file in the canvas, let me just sort of add this as a like a comment, and that is if I want to be wipe out, I don't just want to move a 0 into something because we end up with not a number. But if I do have the 0 value as 0.0, I can use this for clearing a real 8 variable. And this, it still should compile, should have no effect on our program because we're not doing anything. I'm just leaving it here as more of a comment. So if the idea is if we have, or in other words, let's say we wanted to reset the Apple sales and start over. I don't want to move 0 in because 0 is all zeros. It's not a number and not a real number. But here, by declaring this as a real 8 and using 0.0, then it is a number in IEEE notation that is actually held in memory. And now if I take that and load it into a real 8 variable, it's still a real 8 variable. It is a number, even though the number is 0. So I also mention this because this might be helpful later if you're trying to reset something back to 0, that you may need a 0 value. Okay, so I think that's it for this addendum to Irvine Chapter 12. I will load this file into Canvas to accompany the video. This final version of the file I will load into Canvas.